Hi, Erling.
Hi, Anand.
How are you today?
Oh, fantastic.
It's a pleasure to have you here.
Well, you're welcome. It's nice to be on your podcast.
Yeah, that's great. So, today my guest is Erling Andersen. He's co-founder and CEO of the Danish company MOSEK ApS, which is the vendor of the MOSEK optimization software package. His main research interests are computational linear and convex optimization. He has focused on conic optimization and is one of the leading developers of software for that class of optimization problems. He has co-authored several articles published in major optimization journals such as Mathematical Programming, Informed Journal on Computing, and SIAM Journal on Optimization. Since 2024, Erling has been an honorary member of the Danish OR Society. So Erling, thank you very much for accepting the invitation.
You're welcome.
All right. So did I kill the pronunciation of your name? And will you be kind to pronounce it properly, the full name?
Yes, so in Danish we would say Erling Dalgaard Andersen. So the D is very soft and the R is also soft, not like they speak in the Netherlands, for instance, where they are sort of saying, I can't even say it like they do. So Erling Dalgaard Andersen.
All right. So it's not like the Americans will pronounce like Erling or something like that?
No.
Right. So you were born in 1966 in Denmark. From which part of the country do you come from?
I'm coming from the middle island called Fyn, which is there's sort of a peninsula to the left, and then there's two islands, and I'm from the middle island.
Right. Tell me a bit about your parents. What did they do for a living?
When I was born, my parents had a farm with a lot of cows. So my dad is a farmer by education. My mother went to high school, but after marrying my dad, she became a housewife at the farm. So at that time, it was on bigger farms, and the wife would normally make food for the farmer and the people working on the farm and taking care of the whole household. So that's what she did. She never had a full-time job. That was common in those days.
Right. And it seems that your dad had to look for a job in a company after things got a bit difficult in Denmark, right?
Well, so we moved around a bit, and at some point we actually moved into a house. So then, he was no longer a farmer, and then he got a job at a dairy. And later, again, we got a new farm, but that farm was not a full-time work, because in those days, when Denmark entered the EU in 1970 something, early 70s, then the whole society was changing, and you had to have a very big farm in order to make a living. So if you only had a small farm, you would still do some of the farming, but you would have a full-time job somewhere in the industry or something like that.
Yeah, got it. You have two younger brothers. I know one of them also became an optimizer like you. What about the other one?
The other one first, he sort of learned a craft to work with metals and stuff, and later he became an engineer. In fact, he sort of worked more like with production planning things. And today he's CEO of a factory that makes molds for windmill wings.
All right.
Some of the big windmill factories are in Denmark, like Vestas. And so they produce molds, say, for the Vestas and other windmill companies.
Very impressive. And did your family live in Fyn for a long time?
Essentially, my parents had been living on Fyn for all their life, so they lived in different places. So I stayed at Fyn until late 90s, and my brother and both of my brothers are still living on Fyn. Yes.
Right. I know there was an oil crisis in 1973 in Denmark. Was your family affected?
Yes, because, it was a very bad situation. So, for instance, I remember we were living in this house, and in order to save, money on oil, because that was used for heating, then we didn't use the big living room. We moved in a small living room. And one of the things that I can still remember was that you could not use your cars on Sunday unless you have a special permission. So I think at that time we were living in a city, and there we could ride our bikes in the middle of the streets because there was no cars. And so that's one of, not my earliest memory, but one of the memories from my childhood that I still remember, right? So I guess, of course it's different, but I guess it's similar to kids that had experienced the COVID crisis. They will also remember that their whole life, right?
Yeah, it makes sense. At least you had a positive side to that crisis. You could ride a bike freely on the streets, at least during Sundays. That seemed to be exciting. And talking about your memories, what are your best memories from those years living on the farm?
So after living in that city, we moved back to this farm that where we had, I think, 10 hectares of soil, and we had pigs, we had horse, we had dogs, we had chicken. And we liked a lot, me and my brother, staying there because we could roam around the area. We could make a campfire, build huts. Our friends visit us, and we played hide and seek, and were roaming around. There was no computer games or nothing, so we spent a lot of time, playing in the surroundings, going to a nearby forest and things like that. So it was this kind of free life where we, just had a lot of fun playing.
Wow. Based on your recollections, I think you really had a lovely childhood and teenage years growing up on that farm. That's very nice. And what did you like to listen to on the radio during your teenage and early adult years?
So sort of before becoming a teenager, I was quite interested in Beatles. It was not so far, from away, and so they were still very famous, right?
Uh-huh.
Then when I got into my teenage years, we listened to the mainstream music at that time. Depeche Mode, Yazoo, Madness, U2, Tears for Fears, and Simple Minds became one of my favorite bands that I listen a lot to and is still listening a lot to, and had the pleasure to see live last year. Also, me and one of my brothers were quite interested in blues music, so we listened to Muddy Waters, John Lee Hooker, and all those, Otis Spann, and all these names.
Right. Yeah, you mentioned the Beatles. Of course, I'm a Beatles fan, and I started listening to the Beatles because my brother influenced me from an early age. And you mentioned the Simple Minds. Their song, "Don't You Forget About Me," they played quite often here on the radio. So it's still very famous.
Yeah.
Right. And were you into books?
Yeah, so I read quite a few books as a kid. I remember when I was, say, before 14, I liked the books of, say, Jules Verne, then John Le Carré. I read, at the school where I went to school, they had a library. So once every week, we had a half hour we could go to the library and then borrow new books. Later, when I got a little bit older, then I like an author such as John Irving, who had this The World According to Gap. It's also a movie. in my later days, I read a lot of biographies about, mathematicians like Shannon, Einstein, and stuff like that. Gauss. That's what I've been reading here on my older days.
Yeah. And how was your school performance?
Until the end of high school, I think I was probably a fairly average student. And the first 7 years I went to one school, and my parents met my Danish teacher years after I left school, and they talked to her about me and her kids and stuff. And then my parents told her that I had become a PhD, and she was a little bit surprised about that. So I did nothing, no Einstein type of genius or anything like that. No, I didn't do badly, but I did quite fine and finished high school with a decent grade.
Yes, I'm sure you did better than you were saying, but I'll let you by. And you had programming classes between 1981 and 1983, which is quite impressive. Tell me a bit about it.
Yeah, so in the community where we were living, they had all over Denmark, they had a kind of evening school for young adults or in the teenage years. So I went to a course on getting a tractor's driver's license. Or you could also went to one course on learning how to build electronics, like welding or whatever it's called, right? But then as something new there, they had a introductory computer course where they had bought some, initially it was these computers called ZX80 or I think ZX80 and ZX81. So it was some of the first small computers you could buy for home usage. They had maybe 4K of RAM. Really, you cannot imagine how simple they were. And so they had this course, and the teacher was teaching us, like basic, what is a loop, and do some simple stuff and some exercises. And so that was the first course or my introduction to computers. So me and my brother went to this course together and thought this was a really exciting thing to do.
Okay. Did you finally get that tractor's license?
Yeah, I got that. Yeah. So I still have it.
So you can drive some tractors around.
Well, I could without. So there, the point is that if you have a normal driver's license, you can drive a tractor. But if you were below 18, of course, you were not allowed to do that. But with a tractor's license, you could drive a tractor on the real road and not just at home on the fields of the farm.
Yeah, it's very amusing. This is hard to believe. But is it true that you had to do a linear programming project in high school?
Yes. So when I went to high school, they had different brand. Other subjects. You choose a subject. So I did what is called mathematics, physics, and there during those 3 years, I think it was at the beginning of the third year and at the end of the third year, you had to do a project. So the whole class did a project. And so my math teacher, he suggested or he decided that we should do a class on linear programming. And so I think I remember we did some simple model about some baker baking stuff or something. And, he had to mix and decide what to bake. And so essentially what we learned was for a problem with two variables, how to draw the feasible set and draw the orthogonal of the objective, and then use a ruler to find the optimum. I guess most people have tried that. So we had this as a topic. Yeah.
Wow. Did you enjoy it or did you find it boring?
From a mathematical point of view, I found it a bit boring. There was nothing. First of all, who could imagine that this was useful? With something you can draw on a paper. So I thought at that time, integration and differentiating fancy functions and these things are much more interesting than linear programming, because I didn't really grasp how useful this was, because I didn't understand that you can scale it to a huge dimension and did not really understand how it could be used in industry, right?
Yes. Depending on how you are exposed to OR and optimization, that can lead you to think differently about the range of possibilities and applications and the usefulness of the field, right? So
yeah.
I totally get it. And since you were good in math, having even learned calculus in high school, as you mentioned, why did you not try to pursue a degree in math itself or even engineering?
Well, first of all, the other topic that I really liked was history. And so my history teacher thought that I should study history at the university. But I guess, I came there from the countryside, so I'm history, what should I use history for? So initially I wanted to be an engineer, an engineer is something that works at a factory doing something, right? I guess I could imagine that. So mathematics was way too abstract for me. I knew no mathematicians or anything. So initially I wanted to become an engineer. And then we had the opportunity to go to the local engineering school to see how was it to become an engineer. And so I learned that you have to draw quite a bit when you become an engineer, I guess drawing machines or tools or things like that. And if there's something I don't like, it's drawing. So I had to figure out to do something else. Then at the engineering school, they had something they called production engineer. So that's more about planning production and all these kind of things. And that actually sounded kind of interesting. Then I said, maybe I can do the same thing, not becoming an engineer. So I went to the local university instead and chose to do a bachelor in business administration, which also had this planning thing.
Right. I also suck at drawing. I almost failed when I did the basic drawing course in my first semester. Then when I had to use computers for drawing, I was a bit better. AutoCAD and things like that. But I mean, the actual drawing, I'm really bad at it. So what did you study at university exactly?
Where I come from, there's no separate business school, so that was a part of the university. So I did a degree in business administration. It's called business administration and economics, and it's basically a general introduction to the type of things that you use in the industry. So we had basically linear algebra, we had law, we had marketing, we had an OR class, and I just, this is my OR book from them.
Wow.
Andersen,
what about accounting? And
we had also accounting, some finance. We had a little bit of all the topics that goes into it to work for a business. We also had microeconomics and macroeconomics, and that's essentially to me it seems like a branch of math because there was a lot of math. And then later we had this linear algebra course, and one tiny fun story was that I asked the TA, why do we have to learn all this about rank and span and dimension? And but later in my life I used this over and over again,
yes.
Right? But particularly the introduction to OR was the thing that I really that caught me, my interest, and then I got an introduction to linear programming again, and I started seeing, oh, this is potentially a very useful thing to learn.
Right. And did you have a better PC at home by then?
Yes, it was about the time when we started in the university. Me and my brother, with the help of a friend of my brother, imported a PC from the UK, and it's called Amstrad. It had the x86 CPU and was running MS-DOS. And one of the main things was that we got a Pascal compiler for that computer, and we start learning Pascal by reading some books and build program. And this really blew our mind because, basic, when we learned it was a very simple language. It was very slow. So when we got this PC with the Pascal compiler, we could suddenly build much more professional, and not professional, but like real program, right? So that there we could see there was some possibilities.
Yeah, and that was around 1986, right?
Yeah, something like that, yes.
Mm-hmm. You graduated in 1989. What was your final project about?
So my final project was about the Data Envelopment Analysis. So that is a method for evaluating efficiency of like hospitals or things like that. Mm-hmm. Normally you evaluate efficiency by looking at the profit, but university doesn't, at least in Denmark, they don't make profit, or public libraries don't make profit, right? So how do you compare these things? And what you're doing in the data envelopment and analysis is that you try to figure out that you call it a decision-make unit. It's using too much resources with the output that it generates. So like number of different type of surgeries or things like that. And that was a quite hot topic that the professors at my university thought was very interesting. So I thought, let me try and do that. And so essentially what we did is that we made a simple evaluation of public libraries because there was the data available, and that required us to, first of all, understand what was data envelopment analysis and solve some linear programming problems.
Oh, very nice. You mentioned that in high school you found the graphical method a bit boring.
Yes.
And what about the simplex method when you learned it for the first time? Did you enjoy going through the tableaus and all of that?
No, because I always made mistake in the tableaus. I hate tableaus. So because I had this introduction to programming earlier, then I realized, well, maybe I could write some computer program that could generate the tableaus for me. I thought that is fun exercise to do, It is always like, if you get a computer, what should you do with it, right? But then doing the simplex algorithm, I thought could be a fun thing, and I could see the use for it. But after trying to do that, I sort of figured out that I didn't know enough. It was like I couldn't really build a solid Tableau simplex solver. So then I started going to the Mat library at the university and get some books about linear programming to learn a little bit more about the algorithm and how it works.
Okay. Did you find any particular book?
My two favorite books was Linear Programming by Vasek Svartal. And then there was another book by, I think, probably John Nazareth, Computer Solutions to Linear Programs. It's oriented, so basically he tried to describe how linear programming algorithms are implemented in software at that point in time, so they're mid-80s or something.
Yes. The viewers and listeners are welcome to check the Subject to episode with Vasek Schwaltel, where he tells the story behind that book that you mentioned. It's very interesting.
I strongly recommend that episode. That's a very nice episode.
Yes. He's also not very fond of tableaus, and that's completely understandable. And you started your master's in OR in 1989. Have you had the chance to implement a simplex algorithm by then?
I think I had played a little bit with it and probably made some maybe product form simplex, but nothing very sophisticated. But I started reading books and familiarized myself with the topic.
Yes, and you and your brother actually worked on an implementation of the simplex algorithm during the master's, correct?
Basically, when I started my master degree, I took it was called planning, the sort of direction, and I guess you could call it OR. So we were basically having an introduction to the theory of optimization. We had one semester course where we went over the book by H.P. Williams about how to formulate all sorts of stuff. And then the third semester, we had to implement a simplex optimizer. Normally, it was like a product form simplex. They gave this as a project because, first of all, you learned the simplex method, and secondly, it was a good programming exercise. So during that course, I made my first simplex algorithm. I learned the C language in the meantime, so I wrote it in C. It was probably not that sophisticated, but I could solve problems with a few hundred variables and constraints.
Yes, that's not bad at all. And you mentioned that you could solve instances with hundreds of variables and constraints. How did you get access to those instances?
So initially we got like 12 problems from the teacher that we had to solve. We had to hand in a report and solve them and things like that. Then later during my master studies, we had to do a small project and a big project. And so I did the small project on implementing the primal simplex algorithm. There I implemented the revised simplex with LU factorization. I studied different updates, different pricing strategies. And in order to have some more relevant problem, I think probably my brother or maybe we somehow learned that there was something called the Netlib problems. And you could get the Netlib problems by sending an email to a certain address with the name of the problem you wanted in the subject line. But I didn't have an email, so I went up to the system administration guys and asked them, can I have an email? And I thought, they will say no, This is a time where having a phone was a very expensive thing. But the system administrator guy, he said, oh, you want an email? Interesting. What do you want to use that for? Yeah, there's these problems I need for my project. I can get them through email. Oh, here, I'll get you an email. And then I got my first email address ever.
That was around 1990, 1991?
Yeah, something 89, 90 or something, yes.
Incredible. I mean, nowadays, having an email is just a trivial thing, but I understand completely that in the late 80s, early 90s, that was not something that accessible. And what was the topic of your master's work?
So my brother, he studied not the same. He studied something called mathematics economics. They had a lot more mathematics like analysis, topology, and all this in the early years. But sort of the master degree, they could go for finance or OR. So he went for OR. and so some of the courses that we took during the master years were the same courses. And he also had to do a project, and I'm not sure how he got introduced to it, but he heard about entire point methods. So entire point methods, came out in 84. I think Kamarkar's paper is 84. And so somehow he had heard about that. So he made I think his thesis was about the affine scaling, dual affine scaling for linear programming. So when I had to do my master thesis, I thought, let me try this entire point methods. This is new stuff. This is like large language models or something like that today. So let me try that. And my advisor said, yeah, you can work on that. That's fine. And so I decided I wanted to implement the primal dual entire point algorithm in my master thesis. And in fact, I spent a whole year on the thesis, and I have it here. And here you can see.
Wow, awesome.
So I spent my master thesis was basically about implementing the primal dual algorithm for linear programming and also discussing the theory of that.
Yes, and the actual efficient implementation of the interior point method came around that time with Maurício Rezende and other authors, right? They worked together with Kamarkar and published a paper on that.
Yeah, so they made some, and then after some time, it was, kind of our heroes at that time was Losty, Marston, and Shiano. So they had a whole series of papers about the primal dual algorithm discussing, Mahatra also, Sanjay Mahatra also did some work, and Losty, Marston, and Shiano had these papers discussing how do you create an efficient Cholesky and all these things. So it was, I think, Mahatra, Kamarkar, Rezende, and Losty, Marston, Shiano that influenced us a lot at that time.
Very nice. I had the chance to interview Maurício Rezende a few years ago, and he mentioned the story behind that paper and also the experience of working with Narendra Kamarkar. So you finished your master's and began your PhD in 1992. The same year, Denmark won the Eurocup. What are your memories from that event?
Oh, I even in TV yesterday, they mentioned this in 92. So it was something everybody discussed at the time at work, and, we saw it in TV, and the day what Denmark won. So I'm from this somewhat, at that time I lived in a bigger city, Odense, where the university is located. So the whole country went bananas, and I think maybe about 4 a.m, there was no beer left in Odense. You couldn't buy any alcohol anywhere. It's something that is a very big thing in Denmark, yes.
Yeah, and I remember that. I was about 8 to 9 years old, but I remember very vividly, and I was rooting for Denmark. I like the Laudrup brothers.
Yes.
Quite a lot. Yeah, Brian and Michael Laudrup.
There was only Brian Laudrup participated. Michael Laudrup didn't want to.
Yeah, I know. Yeah, I saw that in there was a movie about that,
yeah,
right?
Yeah.
So I realized it. Yeah, but then they played together at least in the World Cup in 1998.
Yes.
Yes.
So the coach, Richard Møller Nielsen, is from Odense, where I come from. He's and he won the national championship for the local club. So he's in Odense a very famous person.
Yeah, and interestingly enough, last year I was in Copenhagen, and Denmark was playing in the Eurocup, right?
Yeah.
So I remember watching part of the game on the streets, but unfortunately Denmark lost that game. But it's an interesting coincidence. In 1993, you submitted your first research paper for publication. You wrote the article on pre-solving in linear programming with your brother. and it was eventually published in Mathematical Programming. Not bad, right?
No. So in January 93, I went to my first international conference called APMod 93 in Hungary. And then there was a pre-workshop about interior point method. So Tamas Telerki was there, Shano was there. So there was a lot of Ganshu, Jacek Ganshu. And they gave, talks on their most recent research. And I think Jacek, he talked about pre-solving. And so then I saw that what my brother and I had done in our master's thesis was about on the same level or something like that. So when I came home, I told my brother, I think we should write up a paper. Let's write a paper about pre-solving in linear programming. Then we did that, and one of the major contribution was I talked about post-solving, which until that point was not something that people had considered, and I tried to organize things nicely. And so we wrote that paper, and then we said, let's go for math programming. Maybe it was a little bit ambitious, but they ultimately accepted it for publication.
Yeah, I checked the paper, and the level of maturity of you guys, it's very impressive. And it's a nice survey, but also with some experimental results, computational results. So
yeah.
Very nice, yes. And that was the first paper of your PhD thesis, right?
Yes, it ultimately went into my PhD, yes.
Mm-hmm. And you spent a good portion of your PhD as a visiting student at the University of Iowa. What did you study there in the US?
So basically in Denmark, when you did a PhD at that time, at least when you came from my university, you could go somewhere for 1 year to get some international experience and interact with researchers that was relevant for the topic of your thesis. And so I looked around, and two things made me go to Iowa. One thing was that there was Yinyu Yi, Kurt Anstreicher, Ken Kortanek, Florian Potra, and they were all quite famous people within the interior point community. So I thought...
it was a hot spot for...
Yeah, it was a hot spot. And Yinyu and Kurt had almost just finished their PhD and were very active. And then the second thing that was that my brother's advisor, he knew Ken Kortanek, which was the department chairman of the Department of Management Science. And he was essentially the one that hired Kurt and Yinyu. And so he sent an email, my brother's advisor sent an email to Ken Kortanek and asked, there's this young man who would like to come and visit you in connection with his PhD. Is that possible? And yeah, he said that was possible. And so it was very easy for me to organize to go to Iowa. So that's why I ended up there. So then I ended up, ultimately I was only supposed to spend 1 year there, but because I was making so good progress on my PhD and I liked it and they liked me, then I ended up staying 2 years at Department of Management Science, as it was called at the time.
So there you wrote your second and third papers of your PhD?
Yes. So the first semester I took some courses, and Yinyu was not there because he was on sabbatical. But then he came home in late fall. He also had a postdoc that worked on implementing the so-called homogeneous algorithm, which was something very new at the time that Yinyu had done with Mike Todd and Shinji Mizuno. And so we had a meeting where Yinyu sort of presented some topics that he would like to work with someone on. And one of them is what's now known as crossover. We call it basis identification. And, it's basically taking the optimal solution from the interior point algorithm and compute an optimal basic solution. And I immediately said, I would like to do that because, I could combine my primal dual algorithm stuff and my previous knowledge about the simplex algorithm. So we started working on that, and then that ended up in a paper that was published in Management Science.
Wow. Yeah.
Then in '94, there was the ISMP meeting in Ann Arbor. And before that, there was a workshop, 2 weeks workshop in Iowa that Kurt Anstreich had organized, where there came, I think Mauricio Vicente was there, Stephen Wright was there, Mike Todd came, a lot of
Superstars.
yeah. And they stayed there for 2 weeks, and then there were some presentations, and we then work in the afternoon and stuff like that. And then the world started moving towards solving nonlinear problems. So Yinyu and I started working on generalize the homogeneous algorithm that Yinyu had kind of invented with Mike Todd and Shinji Mizuno to nonlinear convex problems. And so the next paper we wrote together was a paper that suggested an algorithm, a homogeneous algorithm for solving the monotone complementarity problem. And the monotone complementarity problem is essentially the same as the optimality conditions for a convex optimization problem. So then I worked on that and did maybe a few other minor papers, but essentially the pre-solved paper, the basis identification paper, and the homogeneous algorithm for the monotone complementarity problem was the main papers of my PhD thesis.
Mm-hmm. And the one regarding the homogeneous algorithm was published in mathematical programming, right?
Yeah.
So you had 2 mathematical programming and 1 management science as part of your PhD thesis.
Yes.
It's incredible. And you spent 2 years in the Netherlands as a postdoc at TU Delft. There you turned attention to conic optimization. What motivated you to do so?
Well, so I did this homogeneous algorithm. So I thought, why don't we just solve convex problems directly instead of moving to this conic form? And I didn't get the point about what is a good thing about conic optimization. But then the algorithm for the convex optimization, the homogeneous algorithm, there were some cases where it didn't work so well. And ultimately, I boiled it down to a small 2-variable problem. And I simply realized that it was very hard to solve the problem on that form. And incidentally, the same problem appears in a paper by Robert van der Waay, where he also discussed how to fix it. And I simply didn't see a way of fixing that issue. So then the problem that I was looking at could be formulated as a conic optimization problem. And while I was in Delft, Jos Sturm, which made the software Sejumi, which is self-dual minimization code, so an interior point algorithm, he talked a lot about this conic optimization, and I heard more about it. And then I said, why don't I give it a try to see if it's better? And then, after studying it and implementing, extending my primal dual algorithm to solve conic quadratic optimization problems, then I became a big fan of conic optimization and saw the advantages of doing it that way. And that resulted in another paper I wrote together with Kees Roos and Thomas Telaki from the Delft University that we got published in Math Programming too.
Yes, yeah, you were on fire. So let's talk about the birth of MOSEK. It seems that you wrote version 1 during your postdoc on the weekends while listening to bands like Led Zeppelin and The Doors. Tell me more about it.
Yes, well, so essentially, my brother and I, we had developed software for solving, different kind of optimization problems, right? And he had an affine scaling, and I had a primal dual algorithm. And then, so I had this software for some years, and essentially the only one that was using that software was myself and my brother using his software in order to do our research. But if you had made something you think is great, you would like other people to use it because you get some feedback and appreciation of your work. Initially, I guess I thought that people would ask me about the software, but no one asked about it. So I decided, why don't I try to make a software package out of our software? So we took pieces from my software, pieces from my brother's software. We combined it into a software package. I wrote manual. I made a MATLAB toolbox. I made a C API. I did all the packaging. And I did that during the weekends while I lived in Delft. And then while doing this, I listened to music, and I would usually, during the weekend, I would say, now I listen to Led Zeppelin the whole weekend. So I listen to their different CDs. Other weekends, maybe I listen to Bad Company or something else. Yes.
Yeah. So more into hard rock.
Not really. Hey, yeah, I mean, Led Zeppelin for me is very close to blues, right? Bad Company, as I heard someone say, is the kind of music you want to hear when you're driving across the US on the highway, right?
Yeah. But writing the code of MOSEK was like a ride. So I can imagine that was a nice soundtrack for that purpose. And who came with the name MOSEK?
Essentially, when I had to make it public available, I had to buy a domain. And so I was thinking, I played around with domain names. And so ultimately, I thought of something like mathematical optimization software by Erling and Knud. And okay, that's not too bad. So I thought, can I buy that name? And I could buy that name, and that's how it came about.
Yes, Knud is your brother's name.
Yeah, that's my brother. That's
KNUD, right? The spelling.
Yeah.
Right. Yes. So the fact that internet was starting to take off at that time was crucial for MOSEK to thrive, right?
Yes, because it was extremely important, because I had no way of distributing the software, right? Well, how should I distribute to all around the world so that you could put it on a website where everyone could download it was a very important thing. Without the internet and things like that, MOSEK wouldn't have existed. And so I got, at that time, you could buy an internet connection, but it was using the TV cable, I think coaxial or something.
Yeah.
Yes. And it was very, very fast if no one else was using it. So it was kind of shared. So I had to download, whenever I had to upload a new version of the software or download a lot of data, I had to do it early in the morning or late in the evening. But it worked, and I could set up the website and make my software available.
Yeah, you really had to be a trailblazer to make that available worldwide. And what was available on the beta version of the solver?
So the core part was the interior point algorithm, with pre-solve for linear convex problems and conic quadratic problems. And there was definitely a primal simplex and maybe also a dual simplex. I can't remember if I had the dual simplex at that time. It had basis identification, C API, documentation, and MATLAB toolbox. That's what was available in the first version.
Mm-hmm. And MOSEK was officially launched on April 24, 1999. Who were your first customers, and what can you tell me about your current customers?
I think, I don't know exactly who was the first customers. One of the early companies that contacted me was a company called MATTools that made a compiler for MATLAB, and I made an agreement that they sort of became a reseller. Then there was some forest company using the software because they liked the interior point optimizer. In the early days, one of the bigger customers is Remsoft. Remsoft is essentially it was not directly Remsoft that was a customer, but Remsoft is making something like GAMS, but for forest. So they would have a lot of example models and stuff like that. And they recommended their customers to use MOSEK, or at least suggested that as one possibility. There's a well-known energy software called Plexus. At that time, the company that sold it was called Data Analytics. So that was a young man like myself down in Australia who did a PhD in OR focusing on energy modeling, and then he made a software package, and that had to hook up to a linear programming package. And so he hooked it up to different packages, but among those were MOSEK. And in the early days, we had a lot of contact. I think we would be in contact every day, and he used it a lot. And then there were some financial customers that start picking up the software.
Mm-hmm.
Yeah, so nowadays about 60% of our revenue is from financial customers. So that is big banks, investment funds, pension funds, the big companies on Wall Street. So this is our biggest group of customers. Then we have a quite large number of energy companies doing like unit commitment and what is called the power flow problem. And yeah, I don't know exactly. I can just see it's energy companies. We still have a lot of forest companies. So forest is, if you own forest, you have a lot of things to manage, like forest fires, when to cut forest, right? Because you're growing forest. Should you cut it after 20 years, 30 years, 40 years? Which of your forest should you cut? So you solve big stochastic programming models. So we have quite a lot of those, and then all sorts of different companies. But I think energy and finance is probably the two biggest areas. Bit supply chain, transportation, like bus crew scheduling and stuff like that. We also have some customers doing.
Yes, a wide range of customers. And when you started back in 1999, did you ever dream that MOSEK would be used in Wall Street?
I didn't really have any customer in mind when I made MOSEK, but I think it was already during the first year, a intern on one of the big Wall Street companies, I cannot mention its name, it's still our customer, contacted us, or he started using the software to solve some optimization problems. So, I got one of the biggest Wall Street companies as a customer close to day one. So yeah, I was a little bit surprised in the beginning, but then after that, of course, if you have one, and then of course you can have more.
Uh-huh.
I think if I should say something that I'm really surprised about is how big the financial industry is. It's humongous. I mean, and there's so many companies wants to do optimization, like to put together portfolios for pension funds, making money on trading stocks. There's all sorts of optimization problems in that business.
Yes, very interesting to know that. Why did you drop the continuous convex optimizer?
Okay, so if you want to solve a convex optimization problem, then the algorithm that we had said something like, if your problem is convex and sufficiently nice, we can solve it in polynomial time. But you have no way of checking convexity. Often users inputted a non-convex problem and it would fail. So that was one issue, and then we get support questions. Also, the conic optimizer is more robust. It's way more robust than the general purpose convex optimizer. So at some point, I sort of realized that 99% of the problems that people want to solve in practice, you can solve them on conic form. You get nicer software, it's easier to use, it's more robust, it's easier to reason about. Essentially, the issue is that conic optimization is much closer to linear programming than general nonlinear programming, right? Also, for conic optimization, you can only formulate it the way we do on convex form. You don't have to bother about first-order derivatives or second-order derivatives. You don't have to provide that. You don't have to think about it. It's almost as easy as linear programming to use.
Absolutely. Yeah, it's way more convenient. Because if you think about a user that's not really familiar with the theory of nonlinear programming or convex optimization, the user may often provide a function that's no convex and it gets a weird result, then then ultimately it seems that the software won't suit the user's purpose because of, let's say, lack of proper knowledge. Right?
So also, if some of the algorithms for nonlinear convex optimization, they may require second-order derivatives. Then, okay, this is hard to get right in a program, but then you can use something like AMPL or GAMS or something like this. But those tools, they don't fit that well into the whole software ecosystem that they are using in the financial business. They want something like linear programming where they just feed in some matrices and a little bit of additional information, and then you just run it and then you get the solution. So we fitted much, solving conic optimization problem fitted much better into the whole system that they were setting up.
Yes, I understand. And is it true that MOSEK was the first solver to provide a Python interface?
I cannot say for sure, but when I had to make the website for MOSEK, you did something called your CGI programming. And then later I realized that I could use Python instead of to do some of this programming, and then looked a little bit at it, and I thought, this is great. This is really great. And so I think we were probably the first one having a Python interface. I know one of my competitors has on the internet claimed that they made the first Python interface, but I wrote them back and said, well, I have a manual with a Python interface from before your company was founded. So at least they claim they were the first one, and but I could prove that we have an interface before that.
Yes. So eventually you included mixed integer programming capabilities into MOSEK, yes. Right?
Yeah. So when people come and wants to buy a linear programming solver or a conic optimizer, ultimately they also ask for mixed integer linear programming. So at some point we added that too, yes.
Mm-hmm. And at some point you bought your brother's share of MOSEK. Did you miss collaborating with him?
Yes, but basically I have always been running the company, and he never participated sort of in the daily operations of the company and all this stuff. And then gradually he did less and less for the company. So at some point we decided that I bought the whole part because I was running the company. Essentially we replaced his pieces of the software with something written by me and my co-workers.
Mm-hmm. So you guys did not fight or anything?
No.
Yes. And when did you hire your first employee, and how many people are currently working at the company?
So I think the first one, I hired a student employee in 2001, and he later became a full-time employee. Is still working for MOSEK. His name is Ruth.
Wow, very nice.
Yes. So he had been 23 years at the company. In 2003, I saw some guy named Bo writing about some questions about optimization software on the internet. He was implementing a network solver, and his name was Bo Jensen. So I asked him, are you from Denmark, by the way? It sounded like that from his name. Yes, he said. Then I said, you're welcome to visit me. I was thinking maybe hiring him for working on our simplex code. And then it turned out that he lived just 1 kilometer from our office. And then
That's incredible.
Then he came from an interview, and I hired him, and he worked for MOSEK for a number of years. And then I think after 6 and 7 years, he founded something called Zulum optimization. Uh-huh. But at some point he stopped that too and worked for a while for simplex, and now he's working for some other company in bus crew scheduling or something like that.
Uh-huh. Yeah, so you had to find the guy who was 1 kilometer away from your office on the internet.
Yes. Yeah.
Yes.
So over the years, of course, the company had been growing, and so maybe we had hired one person a year or something, and someone left. So today, depending on how you count, we are about 12 to 13 people working for the company. Four of the employees are working abroad. So we have one in US, two in Germany, and one in Italy. And it's even here in Denmark, we are not Danish, all of us. So there's one from Israel, Poland,
Very
but
international
so
environment.
it's a very international crowd at the company, and the daily language is
Fantastic.
English.
Yeah, that's fantastic. And what has been your strategy to stay competitive in the market?
Well, basically, because we were selling the software on the internet, we couldn't go out with consultants and things like that. So I decided, okay, I want to talk to maybe a bit more sophisticated crowd, people that have a PhD. So I'm not afraid of writing Greek letters in our documentation. I'm not afraid of saying conic optimization, semi-definite optimization, or things like that. I try to talk to people with a PhD in operations research, industrial engineering. Then we had this focus on conic optimization, which were not so well covered by our competitors. Yes, I try to stay closer to the theory and math than some of my colleagues. That's one thing. And the other thing is that I've tried to maybe have someone would say more reasonable prices, right? Because we were kind of selling through the internet directly to customer and didn't spend a lot of money on marketing and all these kind of things. So having a good software for a good price was the thing that essentially was my strategy.
And when you think about building the teams within the company, suppose one guy has to leave. So do you have any, sort of a backup strategy or something that is sustainable over the long term?
Not initially, of course, but right now I'm kind of trying to have, for instance, so there's a team that's kind of simplex orientated. One is integer point orientated. One is mixed integer. One is interface. So I try, each team should be more than one person, right? So if one person leaves, there's still someone who has some insight into that topic, right? So over the last 10 years, I try to, for the sort of the major topics, I try to have 1.5 or 2 persons who has knowledge about what is going on and can take over if someone is leaving.
Right. So now you have redundancies.
Yes. Well, yeah, you can say kind of redundancies, yes.
Yeah. And what can you share about your IT infrastructure in terms of software and hardware?
So we are essentially selling our software. It's available for Linux, Mac OS X, and Windows. So we have to be able to build the software on all 3 platforms. So we have, I think all the developers, except for me, is using Linux. So we have down in our, there's a server room in the basement where we have 2 big racks full of servers. So we have, I don't know how many, more than 60 servers or something like this. And we are running kind of a university-like Unix network with a file server. We do all these things. We use Git and GitLab for source control. We use Jenkins for continuous integration, LDAP for user management. Everything is connected together. There's actually quite a lot of work to have such a system up and running. Of course, you need a firewall, make things secure, VPN access, and all this stuff. By the way, most of the servers, we have 2 clusters with about 30 identical servers, and they are used by the MIP team because whenever they change the MIP code, then in order to figure out whether this change is good or bad, you have to solve a lot of problems running statistic tests. And you do that by seeing that the time is going down, and you cannot run, one day on one server and another day on the other server. So in the cluster, in each cluster, we have about 30 machines that are completely identical. The same CPU, the same amount of RAM, everything. And so you can run a lot of problems in parallel on those servers. And so the times that you get on Monday, you can compare with the times that you get on Tuesday, right? Uh-huh. So that's why we need a lot of servers. The MIP team is basically using those more or less 24/7s to evaluate the changes in the code.
Yes. Very impressive infrastructure you have there. And what we can expect from MOSEK in terms of software development in the near future?
We pretty much like sort of the software that we have, the interface, how you interface it. I know one of the developments that will be available soon is an interface for Google OR tools, for instance. But in general, what we put the most resources into is basically improving the software. The computers are getting faster and bigger, and that means you can solve bigger and bigger, say, linear programming problems, conic optimization problem. So we are working on making the software running faster for the problems and being more stable and more robust. We still have quite a bit of work to do on the mixed integer linear programming optimizer. But essentially, we are pretty satisfied with what we got. We just want it to be better. But of course, I spent some of my time keeping myself informed what is going on, both on the hardware side. So for instance, we added a version of MOSEK for Linux on ARM, but particularly also on the algorithmic side. So we participate in conferences. So I went to the ISMP conference last year. I, of course, familiarized myself with something like first-order methods, what is called PDLP, developments on GPUs and all this stuff. But, whenever we make something like first-order methods available, I'm a little bit careful about these things because whenever we make something available, we have to support it maybe for 20 years, right?
Right.
And also, we don't want too much support or a customer having a bad experience. But something like first-order methods could be something that we want to add to MOSEK at some point when we think it's sufficiently mature and makes sense to add it. But as I said earlier, I feel there's still a big potential for improving what we already got. So we have a nice customer base. And if we make the existing software running 20% faster or 10% faster, they are very happy, right?
Yes.
So this is a little bit different from the research world where you're always chasing the new fancy thing, right? Because you have to publish about it. In the world where I am, it's also sometimes good enough just do things better than what you're already doing, right?
Right. And like other commercial solvers, MOSEK is free for academic purposes, right?
Yes, you can go to our website and download the software. You can get a license that is valid for 1 year by providing your name and university email address. And you can, after the 1 year, you can request a renewal. So it's completely free. I can tell you that on our mailing list, we have about 30,000 subscribers, and most of those are university people. So we have a lot of university users or academic users.
30,000 in your mailing list?
Yes.
Wow. Yeah, that's incredible. And what are your plans for the future? I heard you're looking for someone to replace you as CEO of the company.
Yeah, so I'm 59, and I think Ballas kept working till he was 94 or something. So you never know, but I have no plans about retiring. But at some point, I would like to maybe move from the CEO role to more like a CTO role. in order sort of to make a gradual, retirement plan or something. So that has to happen at some point. We have to locate a CEO. So I took a tiny step in that direction by getting an advisory board. So I have an advisory board with some people on the board who's more knowledgeable about business and stuff like that, where we discuss the future of MOSEK and things like that. But it will not happen tomorrow, but that's something we are gradually working on and thinking about.
Uh-huh. And would you like to leave a final message to our young viewers and listeners?
I guess that should be, I still think that the whole area of OR optimization is a very exciting area. There's a lot of potential working in this area. It's also important that you know some theory. So the theory that you learn at the university and linear algebra and this stuff, it's not useless. It's actually stuff that you can make good use of in real life. And then I think the final thing I want to say is occasionally, people apply for a job at the company, but building software like MOSEK really requires a lot of knowledge. And I know my competitors would say the same, that if you would like to work for MOSEK or one of my competitors, you should probably think about that a bit early and maybe involve optimization software development in your PhD. For instance, go do a PhD with the SCIP people at SIP or something. Then you have a much better chance of getting a job in this business. It can be frustrating at times, but it can also be extremely exciting. When you make new code that runs 2 times faster, you are, you are happy. So I think that's my main message. If you want to get into the business of developing optimization software, start early.
All right. Very nice piece of advice. I would also like to congratulate you on MOSEK in general. Like, it's a big achievement, setting a company and starting everything from scratch and having a mailing list with 30,000 people and having your software being used in Wall Street and, all of that. It's incredible, mind-boggling. And I admire your work. And also, I would like to thank you again for your time. It has been wonderful to learn about your story, the story of MOSEK. And also, I'm sure you made one of my former students, Valton Coutinho, who insisted that I should interview you. He would be, of course, really glad to learn about all of this. Not only him, of course, the viewers and listeners of the podcast. So thanks a lot, Erling, really.
Yeah, I would also like to thank you for interviewing me and for the work of preserving the history of optimization OR. So I really enjoy your podcast and think they will be useful in the future.
Yeah, thanks a lot for your support. And if you want to, spend a few weeks or days in the nice weather, you are welcome to visit us in João Pessoa. I mean, whenever you're coming to Brazil, just drop me a line and maybe we can meet in person one of these days.
Yes. There was an ISMP in Rio de Janeiro.
Yeah, long time ago.
And I wanted to go, but my son, at that time he was 1 year old or something. So I couldn't go, unfortunately. So I've never been to Brazil.
Yes, we should try to arrange something so you can come and visit the country and also maybe present some seminars and try to get to know the community around. I'll be very happy to help you with that. Okay?
Thanks.
Yeah. So, Erling, take care and hope to meet you in person soon. And also all the best to you, your family, and MOSEK.
Thanks a lot.
Okay. Ciao.
Yeah.
Bye.
Bye-bye.